All right, good evening, everyone. In continuation of our architecting course, we are going to talk about the service Elastic Beanstalk, right? As I mentioned, we are just treating services, having an overview of them, seeing what they can do, and then as time goes on, we'll be seeing how we can integrate them and how they can come together to solve a particular problem. We'll be seeing that. But Elastic Beanstalk, let me just start with it again. And just to give a background, there are developers before the cloud. Developers, as I mentioned, used to always have to do a lot of setup before they really actually start developing. So they would need like to have someone set up their machine, install the different software they need before they start doing anything. So Elastic Beanstalk is one of those services that comes to simplify the work of developers so that they focus on developing. And what are they doing? But let's look at the service itself. It makes Elastic Beanstalk is a service that makes it easier for developers to quickly deploy and manage applications in AWS Cloud. We already saw a service that also does this. I just mentioned it. Who remembers it? A service that also does this. I just mentioned it. Which service will you have that will do um, web applications as well as any application? You did see it. It's Amazon Light Sail. Was the name escaping anyone's mind? Okay. Right? Yeah. So just remember that. So Light Sail will come to it again. Um, Light Sail, um, just a moment. This keeps going on and off. Um, So light sail, which we'll come to, but developers can quickly deploy and manage applications in the AWS cloud. Developers simply upload the application, and Elastic Beanstalk automatically handles the deployment details of capacity provisioning, load balancing, auto scaling, and application health and monitoring. So imagine you want to set up an application, but the whole process of having a load balancer set up, doing auto scaling, then configuring CloudWatch for monitoring, those are many things. But if you have a service that can automatically handle all of that, capacity provisioning, load balancing, auto scaling, application health monitoring. So this is one example of a service that can make it really easy for developers to build applications in the cloud. So developers focus more on building applications than thinking of how do I set up the load balancer? How do I set up auto scaling? How will it be monitored? Do we see the advantage that Elastic Beanstalk brings for developers? Yeah. Sonia Hilda Rudolph, hopefully we see it makes it easy.
Yes.
Yeah. Imagine if you were to open a restaurant and there was a whole company that just helps you find a location, set up everything, and you just get in. You are a chef. You just want to open a restaurant, and you get in and you just start cooking. You're not bothered about. You just explain how you want your restaurant to be set up, the building, how the kitchen wants to be, right? And all of that is just done, and you just walk in and you start cooking. So that's what Elastic Beanstalk is to developers. Developers are more about doing applications, not doing the capacity provisioning and error, I think. So who should use Elastic Beanstalk? Those who want to deploy and manage their applications within minutes in the AWS cloud. You don't need experience with cloud computing to get started. AWS Elastic Beanstalk supports Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker web applications. So if you've been doing development in any of these languages, and you are going to AWS, you don't need to waste so much time studying. You just use Elastic Beanstalk and it will just give you the environment you need to develop as you have been doing before. So, so this is Elastic Beanstalk again, web applications, and that's basically what it is. Um, Amazon Light Sail is similar, but the difference, discussed Light Sail, the difference with Light Sail is that it comes across with pre-configured development stacks. Again, it makes it even far simpler. So um, with Elastic Beanstalk, you need to just provide your code. With Light Sail, it has pre-configured stacks, right? So you can just it goes a step further to make it easy. So you can just there are already pre-configured templates that you can use for your web development. In Elastic Beanstalk, you still have to be doing some development, but if you are just looking for a template to use, you can then just go for Light Sail. Always remember that the more you are getting like pre-configured templates, all of that, the less you can customize it. Rudolph, you were asking the question of that question of self-hosted customized database. And I told
Yes.
you it's best, yes, you see, it's best with EC2. When there are some engineers that they may look at what AWS is offering and they feel like it has been too customized in a way that they don't want. It's good, but it's customized in a way they don't want. They want to do it their own way. So if you are very gifted and you know how to customize it, then you can use EC2 and start everything from scratch. So the more AWS have something customized, if you are okay using it the way it is, that's fine. But if you want to tweak it a bit and do a few things, and you realize that maybe what is being offered is not giving you that capability to customize it as much as you want, then you fall back to using from EC2. So this one has pre-configured templates. It's good for some people. The templates are just good enough. They will use it. But the restriction is if you realize it's not the templates that you cannot customize it the way you want, or if the customizations it offers just to a certain extent, then you have to fall back and do the development from scratch on your own, which is okay as long as you have the knowledge to do that. Yeah.
Excuse
So
me,
just
sir.
keep that in mind. Right.
Yes, Elastic Beanstalk and Amazon Light Sail an application under platform as a service.
Beanstalk is falls under platform as a service. Uh, no, no. What are we saying? You have platform as a service. What do you have again? Infrastructure as a service, platform as a service. Yes, Beanstalk falls under platform as a service. Lightsail is not under platform as a service. Will I put Lightsail there? But Beanstalk is definitely light. Let me just confirm because these services at times. But Beanstalk is definitely an example of platform as a service. Lightsail is almost, but just to be sure, it's never wrong to quickly check. Um, Platform as a service. You see, because of you see, that's why it says that Lightsail is considered as infrastructure as a service because it works similar to EC2. Right. So I'm reading that here. Let me just confirm. Why I was checking, that is because I've never, most of the time, the example given for platform as a service is Elastic Beanstalk, but not Lightsail. I don't know whether I should try Patchlock, but from what I've just got from Google AI, is given it as a infrastructure as a service. And I can understand because when you go to Lightsail on the console, it asks you to pick the instance and then it comes with some information for it. So it says, so it's Lightsail. Log, files. Amazon Lightsail is technically IaaS, but it's IaaS made very simple. So there you go. It's infrastructure as a service. Okay.
Yeah.
All right. Thank you for the question. Okay. Um, right. So that's the key thing. Just remember that with Lightsail, it comes, that's the key thing that makes it different from Elastic Beanstalk. It comes with pre-configured templates. Yeah, at times you see questions talking about web development, web applications, and then maybe somewhere in the whole long sentence they are talking about pre-configured templates. Don't be quick to say it's Elastic Beanstalk because Elastic Beanstalk also do web development, also do applications. Immediately you see pre-configured templates, it's Amazon Lightsail. Yeah. That's the key thing that makes it different. And that's what makes it unique as well. Um, I did talk about tax. Anyone here remembers when we did what I did talk about tax? It's just not much to talk about it when we were doing the revision. Tags are just names that are just labels that you give resources you create. Anyone remember what I showed about tax? Or I need to go to the console and show again. They are just labels that you give resources you create. Anyone remembers?
Yes.
Oh, we have forgotten. You remember Hilda? What about you, um,
No.
Rudolph? Okay, let me quickly show that again.
Yeah. I
Resource
remember.
dot. Yeah, I just want to be. Mm. So it's when you want to create any resource, just look around. Let me just pick S3. Right? You always see it will give you the option to create to add tags, right? So tags again are just labels that you give resources to identify them. So if I click create a bucket here, right under here, you see tags. You can use bucket tags to analyze, manage, and specify permissions for a bucket. So I want to create a bucket. It's always a key value pair. I mean, maybe this bucket is just to store testing information that I'm using in the, let me say, um, it's a developer environment. This bucket is going to be used in the development environment. Then I will just call environment, and mostly they will just put env, and I'll say the environment here is developer, mostly referred to as dev, right? Okay. Maybe so which project? I can say project. This project is for what? Let's say we found cloud. We say we found cloud. Um, we found cloud beta. Let's say there's a project we call in we found cloud beta. I can add as many tags, 47 tags, right? You can add up to 47 tags. I can maybe who is the owner of the project or whatever. I could give a name, right? Owner could be Barry. So tags are just labels that you give resources that you create. So this is for a bucket. I can go ahead and create the bucket. The bucket will have all these tags. And what will happen is I can decide and search for all resources that belong to development, all resources that have the tag env development will then show to me. So this will involve not just buckets, but EC2. So it's the same thing. When you come to EC2 and you are creating an EC2, you also have the possibility to give tags. Basically, anything you create in AWS gives you the possibility to create tags. You see, when you write the name here, if I type name test, actually, if I click additional tags, you see the name is test. I can say environment, dev. I can add another tag, project, and I can call it from cloud beta also, right? I can see add another tag, just like we mentioned, owner. Maybe bear is the owner screen of this EC2. So if something has to be done on it. So I can be, when creating resources, it's advisable to always add tags to any resource to resources you create. Because what happens is if you have many resources and you are just interested in all resources that are environment dev, you can then use this to filter to search for them in your account. And maybe you are searching them to delete them or you are searching them just to know what's going on here. But tags are just labels that can be assigned to resources. They are at times referred to as resource tags anyway. I hope that's clear, Sonia, right?
Yeah.
Good.
So
Yes.
please, can you just give us a specific distinction between Elastic Beanstalk and light sales, Amazon light sales, to better understand?
Did anyone get a distinction I gave?
Yeah, you said
Did
the decision is that the the light scale is pre-configured already. It's a bit more simplified than the Elastic Beanstalk. So it has been pre-configured, and the Elastic Beanstalk, the developers can quickly and easily deploy and manage. But with the light sail, it has already been pre-configured in a way that the template makes it much more easier than with the Elastic Beanstalk.
Right. So yeah, that's one example I was giving. So if you notice here, Hilda, I was talking about pre-configured templates is what makes it different from Elastic Beanstalk in terms of web development. So when you are using light sail, you can just use that's one of the key difference. And if you want to check more, we can also use here, right? If you want to dig deep into that, the main difference between Elastic Beanstalk and Amazon. I like this because Amazon license is like buying a complete chop box lunch package from a street vendor. Everything is bundled together, rice, chicken, plantain, all for one fixed price. You don't choose individual items. You just say, give me the small box or give me the large box. Simple, straightforward, no wahala. But Elastic Beanstalk is like going to a proper restaurant where the chef handles all the cooking, but you choose the ingredients, the spices, how spicy you want, which protein, which size. The chef still does the work, but you get plenty control over the recipe. So Light says simplicity and predictability. Beanstalk developer focus pass. You bring code, AWS handles all of that. Light Sail is best for simple workloads and beginners. It's not a simple workloads. This one, you really still do your code and you have full access to underlying resources, auto scaling indeed, but here you don't have, right? You can still do some control here. Just like you go to the chef, you still control how many spices you want. But when you are just buying jollof already packaged in a box, you just take it and you go. When you go into the restaurant, you are making an order, maybe you can say which ingredients and things like that. I don't know if it's making sense, Hilda.
Yeah. A little bit.
A little bit.
Mm.
So Lightsail comes with pre-configured templates. Elastic Beanstalk does not come with pre-configured templates. You still have more control. Yeah, that's the best. Yeah, maybe it takes some of these things takes time to sing. So Right. Maybe when looking at questions, if you still struggle, we can talk about that. Yeah. All right. I wanted us to talk about cloud formation. I'll introduce it a bit, but let's properly discuss it today. So the whole concept of infrastructure as code is something that also came later. And the main challenge here, which we can all agree, like I mentioned, imagine if you were to if you were to start creating, let's say you're in a project and they say they need about 10 EC2 instances, and then maybe 5 to 10 S3 buckets. And you are not just building EC2 instances to be on their own, they have to connect with maybe an IBB and an auto scaling group with a load balancer. If you sit down and you are doing these things manually, and maybe when you finish configuring it, say in the London region, your boss says that, okay, now that it's working in the London region, can we have it running also in the Frankfurt region or maybe the American region? It's it can be just tedious and time consuming, even in a project where you are just focused on your own area, because setting up the VPCs and all those things, doing it manually, no one does it. When we are studying, you can always start from that point, right? Learning bit by bit. But being able to really deploy complex infrastructure and also a huge amount of resources needs needs to be done more automatically than doing it um, using basic just doing it manually. So infrastructure of code come to address the concept of how can you build resources in a way as if it is code. Right, so it's a very revolutionary kind of how can you pull it? It's an idea that is just changes so many things. These are things you could not even think of doing it in traditional IT, because how can you say you can automatically create servers? Servers are physical, you must carry them and bring them. But you have the possibility of creating resources by writing code. And the key thing is once you create that code, you can say, okay, take this same code, deploy the resources in London region. You take the same code and say, deploy the same resources in the Frankfurt region or in North Virginia. It will come out exactly the same. So that is why repeatable manner comes here, right? If you notice here, you treat infrastructure as code, you provision resources using you provision resources using code instead of AWS Management Console. You provision resources in a quick, safe, and repeatable manner. Take note of that. It's hard to be able to create resources in a repeatable manner. Right? Repeatable manner at times is a phrase that may come in question when talking about provisioning resources. You use infrastructure as code. So components like operating system, database, storage, and other infrastructure, developers must always set up, update, maintain these regularly, which is very time consuming. So manual configuration is prone to error. Humans, we are not perfect, no matter the best engineer out there. Automation is what makes things almost work perfectly, right? Once it's automated, computers are very good in doing something repeatably and also without making an error once it has been configured to be doing so. So doing it manually becomes difficult to manage it at scale. So comes in infrastructure as code, which is more of you define the desired infrastructure state without manual step. You just write step of what you want. You can just say, I want an EC2 instance. It should use a particular instance type. You should use a particular AMI. You just write it in a format. You give it to the service, and the service create the instance. You can go as far as defining a VPC, defining subnets, and then defining the EC2 instance to be deployed within this VPC. This VPC should have an internet gateway. All resources you can think about, you can all define them, they are connected, and then you give it infrastructure as code, and it will create all of that for you. So this frees developers to focus on application development as well. And then you can be able to create your infrastructure always without making errors, right? It helps you also cost control, optimize infrastructure spending. With infrastructure as code, you can know exactly what has been deployed. It is faster also, response enable quick adaptation to business needs. If you create this if you create this code, what happens is once you create this code, if it has an instance of type T3 micro, and maybe at some point you want a bigger instance, you just come to the code and you change it to maybe the different instance type you want, and you give it infrastructure as code, it will read it, it will recognize that, okay, all these other things have been created. I just need to change the instance type, right? And then it will go follow the process and do the replacement, right? So, so that is the key thing about what infrastructure as code has come to do. It's trying to avoid the manual creation of infrastructure as code, clicking on the console, which can lead to so much error. You learn more about infrastructure as code. There's a special course dedicated just to that, and a topic also for if you do the AWS developer certification, there's a whole topic on that. And but also, yeah, like I already did a small demo of how it works. Yeah, we'll also see it also in the lab. It's very, very easy. When you look at, once you have seen the first code, the good thing about it is there's already a lot of code that is existing, and at times you just need to take it and how do you call, and adjust according to what you want, right? So normally that's how everyone starts. Look at what is already available, and then you decide uh, which one you decide to use. And then as you gain experience, you start writing your own as well. So with CloudFormation, you always create a template that describes all resources that you want. EC2, RDS, and CloudFormation takes care of provisioning and configuring those resources for you. You don't need to individually create and configure them any longer. AWS resources figure out what's dependent on what. Because when creating resources, let's say you want to create a VPC, you want to create subnets, you want to create an internet gateway, and you want to create an EC2 instance inside that. Once you put the resources, CloudFormation will be able to know that to create an EC2, it will need, that connects to the internet, it will need to create the VPC first, and then it will need to create an internet gateway. It will not create an internet gateway and then be wondering where it will go. So CloudFormation has the capability that looking at the resources you have defined, it will be able to understand the dependency and know which one to create first, right? So that there's not a situation where it tries to create an EC2 instance and realize that the VPC has not been created that is specified, and then maybe it crashes. So CloudFormation is able to understand and deal with that. You don't need to worry about that. So this is how it flows. I did show that example, a sample example. So this is basically the workflow. You have a template, which is called a logical resource. A sample template, you just write my EC2 instance. This is all of this is given already by AWS, all this area, this first type here. Then the properties, these are the things you are changing. For example, you want to define the Amazon machine image. You want to define the EC2 instance you want. You want to define the key that you are going to use, right? This key. If you want to add some storage, you do it, right? Delete on termination, that means when the instance is deleted, the storage will also be deleted. That is something here. So this is the logical resource. So you start by just writing this in what is called a JSON format, no, YAML format. YAML, there are two types, YAML and JSON. The format that is popular is YAML. So once you do all of this, you give it to CloudFormation. CloudFormation reads it and create what is called a stack. So CloudFormation stack, and then this stack is the one that is then leading to the creation of the physical resources. Then you start seeing the resources appearing in your Amazon console. So you write all of this in a code, uploads it, go to CloudFormation. You remember how I showed that? Let me show it again. So if I come here to CloudFormation, right, create manage resources with templates, you write what is called, you take that code and you write it down in a document. Okay. So I come to create a stack here. It will ask me, I can either have it already sitting in an S3, I will bring the link, I'll paste here, or I want to upload it, I'll go to upload. It can be in JSON or YAML format. These are just formats in which you can write. Then you choose that and you upload it. Once you upload it, you just click next, next, next. And that's all. CloudFormation will be able to read the information you have provided and then go ahead and create the resources. Any question? Are we there?
Yeah, we are there.
Okay. No question is what I get. Right. Yeah. Yeah. So let's look at the next service. AWS Cloud Development Kit, CDK. This is also used in development. Now, there are some people who are very excellent programmers. They can write in Python, TypeScript, Java, and what is called .NET. They are very excellent programmers. Then they want to use AWS. Then they realize, to be able to create resources, I need to learn CloudFormation. And for them, it's like, why learn another? I already know Python. Why should I start learning how to create it using CloudFormation? If you are coming to the cloud new and you don't yet know Python, CloudFormation could be just good to learn. So these people who are already good in some languages, AWS decided to create the service AWS Cloud Development Kit. And what this does is you write how you want your infrastructure to be created using the language that you know. And the language that is supported is TypeScript, Python, Java, and .NET. I'm sure the lists have increased. When you write it and give it to AWS Development Kit, it will take it and in the background form a CloudFormation template so you write it, but in Python, Cloud Development Kit will take all of that and convert it to a CloudFormation template, and then with that, it will provision your resource. So it's like moving a step back. You can decide and write all your code using YAML and then you give it to CloudFormation, and it will go ahead and provision your resources. But if you say, I don't want to start learning how to write CloudFormation. This is a CloudFormation service. I don't want to start writing CloudFormation templates because this is the template. I'm using CloudFormation in different places. This is the template, CloudFormation template. You write it, you give it to CloudFormation service. It takes it and then it provisions the resources. I'm like, I know Python. Why should I start learning how to write all this? Okay, AWS says no problem. I'll give you the service called AWS Development Kit. Development Kit. And what you do is, okay, you say you know Python. You are very good in Python. You write everything in Python. You give to AWS Development Kit. AWS Development Kit transform all of that into a CloudFormation template, and then CloudFormation template, which is then handled by the CloudFormation service, and then it still gives you resources. So AWS Development Kit is for people who are very comfortable defining resources using a program of their choice. Does that make sense?
Please repeat the process of the process of the AWS Development Kit.
Okay, no worries.
Let me just take you back a little bit before you answer Rudolph's question.
I'm
Before
listening.
you come back to the cloud kits. This cloud formation, right? We talked about infrastructure as a code. Is it a is it what cloud information is all about? To create infrastructure as a code that allows us to manage AWS infrastructure in a code template.
Okay, I'll come back to that. Let me explain this first. I'll come back to that, okay? So, as I mentioned, right? I hope Sonia, I hope you're also there, right? Hope baby
Yes,
is
I
not
am.
attending
Yeah.
alone. Right. So in the CloudFormation, when you are writing, you can write, I mentioned you can write CloudFormation templates. And you can write a CloudFormation template, mostly written in what is called a YAML format. It's just a format in which it is written. When you write it in CloudFormation template in a YAML format, you submit it to CloudFormation service. Just like I did, I showed the code. I'd use the one for an S3 bucket. When you write it, you upload it to CloudFormation and you just wait. Your resources will then appear. You understand that, Rudolph, right? In your question, do you understand this first step?
Yes,
This first
yes,
one,
yes, for
right?
CloudFormation. Yes.
Right. Now, I may say, I want to provision or I want to create resources in AWS, but I'm a good programmer. I can configure that in Python. But AWS don't have a direct way where you can just write your code in Python and give it to CloudFormation service to create resources. So AWS decided to have a service called AWS Development Kit. That's the service we were discussing. It gives you the AWS Development Kit called SDK, AWS SDK, right?
Yes.
So you have the AWS Development Kit, AWS, this is the
CDK,
service, Development
SDK.
Kit, the AWS Development Kit, right? And you you define whatever thing you want to define in Python, but you give it to the AWS development kit here. It takes it and then it creates the CloudFormation templates for you because you submit it, and then once it's created, then the process just continue as before. So the service here is taking whatever, it's like, how should I put? It's like two people want to talk to each other, but they need a translator. You have person B here, you have person C, and then I cannot, because C cannot directly understand B, I bring A here. So I talk to A and then A talks to B. It translates it to B. So Python, you write it in Python, you give it to the AWS development kit here. It takes it, gives it to, and then it comes to YAML and then it goes to CloudFormation service.
So,
Did that make sense?
yeah.
Right. So you define your application resources using the familiar programming languages that you have. So the AWS Cloud Development Kit or the AWS Development Kit is an open source software development framework for defining cloud infrastructure as code with modern programming languages. It can be TypeScript, it can be Python, Java, or .NET, and then it will deploy it through CloudFormation. So the relationship between AWS SDK and CloudFormation. So when AWS SDK applications are run, they compile down to fully formed CloudFormation YAML templates that are then submitted to the CloudFormation service for provisioning. Right? So that is how it works. That's where CloudFormation just comes in to help those who know. Now, on the question Hilda was asking, infrastructure as code is just a topic, right? It's a topic, and the service in general, there's something called, just like when I started with encryption, I went back and I defined all those things, and then I said in AWS, you use AWS KMS if you are doing encryption. So infrastructure as code is also a very general concept. Terraform is another way to do infrastructure as code. CloudFormation is another way to do infrastructure as code. But the first thing is you first of all need to understand what is infrastructure as code, right? Infrastructure as code, just as it said, infrastructure as code, that is just IaC, that is just it's self-explanatory. So infrastructure, and rather than going and creating it manually, you instead write code, and this code contains the infrastructure you want to create, and then you give it to CloudFormation, and it goes ahead and create that infrastructure or provision that infrastructure for you. So infrastructure as code, you define the desired infrastructure state without manual steps. You are just writing, and the example like I showed was something like this, right? This is an example of how all of this is the infrastructure you want to create. You want to create an EC2 instance. That EC2 instance has to be of type T2 micro. It has to have an AMI. It has to have a storage. Those are all infrastructure as what I want. But I write it in a format, it looks like code, because when you think of Python programming, it's like code, but not really like programming, so to say, but it is in code format. So I write my infrastructure in a code format, IaC. Once I write it, I give it to the service called CloudFormation, right? When I'm writing it, it is what is called CloudFormation template. All this, the way I'm writing it and presenting it is called a CloudFormation template. When I give it to the CloudFormation service, it creates what is called a CloudFormation stack, and that stack goes ahead and then deliver your resources. So infrastructure as code is just the definition of how you can go ahead and provision resources without doing so manually. I don't know if I'm answering your question, Hilda, or you can ask.
Yes, you've answered it. Because I was thinking that the infrastructure as a code is a topic on its own without being attached to the cloud formation. Maybe it's just one of the structures that you create on its own.
Yeah. So infrastructure as code is just a general definition, and then in AWS, you can do infrastructure as code using the service called CloudFormation. Yeah. You can also use Terraform. CloudFormation is specifically is a service in AWS. Terraform is more of, they call it cloud agnostic. What it means is it's been created by a complete different company, but in AWS you can also use Terraform. If you go to Google, you can use Terraform. If you go to Azure, you can use Terraform. So there's a complete separate company. It's called HashiCorp. It was bought by IBM of recent. HashiCorp created the language of how you can provision resources, and you can still use that in AWS. You can use that, their same Terraform, you can use it in Google, you can use it in Azure. But CloudFormation is created by AWS and you can only use it in AWS because, yeah, it's been created by
Cloud
AWS for
formation,
AWS. That's this one.
can it be reused somewhere else?
When you say somewhere else, where do you mean?
Like for instance, if you create AWS EC2 instance, can you use the same template to create in RDS or database?
So there is a different definitions of how, if you want to create an EC2 instance, the format of how the resource is defined is different. If you want to create an RDS, the format in which it is defined is different. And there's a documentation on how to do that. But like I mentioned, it's formation. You can see that on the AWS. Let me show you. So for everything that you want to create, AWS have a definition and examples of how that can be done. Template reference, right? So any service you want to create, it has. So that is resource and property reference. So for example, I'm going to look for RDS. And you see how it's different from EC2. Okay, or let's just use Amazon RDS. Okay, we can look at Lambda. It doesn't matter, it must not be RDS. What I'm just trying to show is for every service, we have seen many different services. We have seen CloudWatch logs. If I want to create AWS config, right? I choose Lambda here. So you can go ahead and see resource types to create. This is the YAML format. If you want to create a Lambda with you see it's defined. There are examples. AWS, it will be explained how it will be done. But that's why I created the AI service so you can quickly answer things like this. Well, also let me show here. An example of an RDS cloud management template. You give us one. And you see how it will be defined. So it's completely, the template will be different from EC2. Where did I type? Okay, I typed in the wrong place. The question should be here. Excellent of RDS. I know this can answer a little bit more than it's supposed to, but that's not a problem. You see, so this is a template if you want to create an RDS, right? If you notice, resources, my database type, This is what is important. AWS have this difference. Properties. You define the identifier, my shop database. It's like the name. The DB instance class, you want it to be DBT3 micro. What engine should I use on it? My SQL. Master username, master password, and all of this. There are many things you can still define, but this is an example of a template for RDS. Do you see that, Hilda?
Yes, sir.
Right?
Yeah.
So if you decide to say, let you look for the one for EC2, you see that it will be completely different. So you cannot reuse the template for EC2 is different from the one for RDS. That's what I want to mention. All right. So, but AWS have all the, you can look at, if depending on what you want to do, you can always look at it. You can always, all of it is listed. And of course, when you do the cloud formation, course, you also see that. An example on an EC2 cloud formation template. It did not give me, spend time explaining. Okay, it did not give, but I already showed one on the definition here. So this is one. Or for EC2, you see the type here is AWS EC2. So the type here is what will always change. Right, it's always going to be different. So you can take a template for one resource and use it and try to define it for another resource because all of them have different properties. Yeah.
So must the template file be always YAML or yes JSON type?
JSON. Yeah.
Okay.
Yes. It can be either YAML or JSON. Yeah. Yeah.
Mm.
All right. Good. Any other question? I think this is outdated, but I don't know if it still comes into questions. Let me see. If it's outdated, the AWS Work Service has reached end of life. Yeah, I'm not sure. Yeah, the last time I was having it, but it was still appearing in the exams. What this is like in traditional IT, there were already some approaches that engineers were creating in trying to build because before the cloud, we did not, there was something called virtual machines, which was also used in traditional IT, which was like a bridge. Then we moved to the cloud. Like you notice, AWS here have EC2 instance, as we said, it's a virtual machine. So in traditional IT, engineers were already creating something almost similar to cloud formation, like how to provision servers quickly. They had what was called Chef and Puppet. So what AWS did was AWS created something called AWS Ops Work, which was something compatible with Chef and Puppet that was used in traditional IT. But it's now out of its end of life. AWS no longer supports it because there has been a huge transition in the cloud, and many people are focusing on, if you are moving to the cloud, focus more on using the existing infrastructure as code. Terraform and CloudFormation are the leading as skills when it comes to doing infrastructure as code. So OpsWork is no longer supported by AWS. And I'm not sure it's still in questions because anything that is no longer useful, maybe when we're revising it, we may see it, but it's not, I don't think you cannot see this in the exam because when something goes out of service, AWS no longer tests you on it because it's of no use, right? But I'm mentioning it in case you see it in a question, ops works, yeah, because some of the times tutorial dojo also don't update as soon as things change. What I want us to look into is system manager because it's a very important service and you see a lot of it. AWS System Manager, and it basically manages EC2, and take note, as well as on-premises systems at scale. So imagine you have created so many EC2 instances, say 50, 20, 30, and then you want to, let's say, update them. We have already discussed the challenges of moving from one instance to update them. When I say update them, it's like all of you have a Windows machine, and once a while you get something that comes up saying that new updates, how do you call it again? Is it updates? You need to install and reboot your computer, right? In Windows, how do you call it again? It's updates, right? It's updates.
It's
There's a word that
mhm.
is, it's, yeah. So machines, all operating systems are always getting updates once in a while from the call it, should I say, developers. Like when you have your Windows machine, there may be a security update. Maybe they have realized that okay, this attackers can now exploit the Windows system. Then they create an update that you need to install in your computer and restart so that it should be protected. So all computers and even in the cloud, they still receive updates. So if you have many EC2 instances and you want to manage them, and companies have many EC2, you can see a company with 50, 100, 500 EC2 instances, depending in just just let's say in a department. So, and if you need to manage all of them, let's say there's a critical update and you need to install it on all those machines and restart it, there's no way you will be moving from one computer to another to do that. It's exhausting and also it's prone to error. But then you have something called AWS System Manager. When you say manages, that you can be able to just all these instances that you have can have something called an agent configured in it. And then once wherever it has an agent, you can group those instances and you can just give one command and say install it in all the 50, 100, 500 machines. And it will go and it will install. And if there is any error anywhere, it will show, it will be able to display to you. So System Manager is a service that helps you manage EC2 instances, but also on-premises systems at scale, because the bigger they are, it's able to do that. It simplifies application and resource management. It shortens the life to dictate and resolve operational problems. So most of the process of installing updates and restarting your machine is what is actually always referred to as you are doing patching, right? So let me show again, showing it on the screen makes it looks less complex. Systems, what's called systems manager. AWS System Manager is a central place to view and manage resources. It does a lot of things, but one of the key things is manage EC2 and on-premises instances. The key thing is in on-premises instances, you just need to install what is called the agent, the agent on it. So what you can do is inventory. Let me look at inventory here if it has any of my systems, but where am I? I'm in AP South. That's in Asia Pacific. Let me try to use Ireland. I have some 2 instances running in Ireland. I don't know if I did activate. Okay. Okay, I have an Ubuntu instance here. It's dictated here as one of my instance. So what you can do is you can create instances and you basically put them in groups and manage them. You could have instances that belong to Fleet Manager, instances that are, let's say, in the development environment, for example, right? And this is where you see that tags are very important. Then you look for all instances. Like I have an instance here running. There's an Ubuntu resource instance here. It's being managed by instance manager here. But this is not what I was looking for. I'm looking for, maybe let me look at patch manager. So if I have many instances, imagine I have instances in the develop environment, I have instances in the production environment. Then there is a security issue, and I want to first, you don't always take things and install immediately in the production environment. But what I can decide to do is I put all instances that are in the development environment in a particular group, and then I go ahead and install the updates on them, see how they respond, and if they are working well and there's nothing wrong, then I also go ahead and install them in the production environment, right? So, so the key thing for system manager is that you see patch compliance is ensuring that your instances are complying with the latest updates. In technology, when you are working, you hardly hear they hardly say updates in tradition, in not traditional, in a layman's language, you always say that install your Windows updates. But when you are working as an engineer and in cloud, you always hear patch, you are patching your system. And patch compliance means is your system having the latest updates, or is your system up to date in terms of all the security updates that are available, right? So you can decide and create your instances. You can decide and take all your instances, put them in a particular group, and then go ahead and ask um, and ask session manager to patch them. And it can be, so this can be done automatically. You can decide and say all of that should be done at 1 a.m. because you don't always want to do patch management when people are using the system or when it's live. You may choose a time when it should happen. You have a change calendar where all the changes are happening, or what is called a maintenance window. In most systems, they always know that, okay, there's a certain maintenance window where some work can be done, and you may get an announcement saying the site may not be available um, at this time, maybe at 1 a.m. because they know, but at least in not every company does that. There are many companies that will always inform ahead of time that we are going to do some maintenance work, and some of it could be patch management. Some just go ahead and do it, and you may just notice that there is some sluggishness in the site, but it's never so serious. But it just depends on how any company works. So back to what we were talking about. System manager manages EC2 and on-premises systems at scale. It simplifies application and resource management.
Can we be a bit specific? You said manages EC2 instances and on-premises systems. And we saw on the console there that uh, the system manager simplifies applications and resources and resource management. Central place to view and manage resources. So are we talking not only of EC2 and other resources as well?
Yes, so resource is a general word. EC2 is an example of a resource, right? Under the EC2
Yeah.
service, right? EC2 is an example of a resource.
So we should not just stay there that manages EC2. Can we just change that EC2 and put resources there?
No, that's an example, and I went ahead and said simplifies application and resource management, right? This one is just manages EC2 and on-premises system at scale. That is true. Resource management, EC2 is an example of a resource, simplifies application and resource management. So this is not saying that it's only EC2. It is any resource that is under that can be managed by a system manager.
Yeah.
Does
Is
that
it
help now?
It's
If you
okay.
notice also here, helps you manage your AWS resources securely at scale. You see, I keep bringing AWS resources. This one was just because most of the time when you are starting, it is always EC2 and on-premises instances. But as you go along, you realize it's also any AWS resource that is capable of managing because it's not all resources. For example, S3, it will not manage, but yeah. But as you go along, you see the ones that it can manage and it cannot. Okay. Yeah. Hilda, what are you saying?
I wanted to ask if the service, if it's a management and automation service.
In what perspective? Just to be sure that I get what you're saying. Yeah, you can do automation with
Is
it.
it an automated service?
Automated service.
Mhm.
You can configure it to do automation for you. Like I was giving the example that you can put instances and then you say that at 1 a.m. it should install the updates. That's an example of automation it can perform,
Yeah.
right? And at the same time, it's managing those services. So you can configure it to do automation. That's a yes. Yeah. If with the example I've given, yeah. Right? You got it here, right?
Yes. So,
Okay.
but why
So
is it
this
that why is it that if you can configure it to, like, let's say you have 50 EC2 instances that you have created, you configure it for them to, you automate it for them to update or give a latest version. Can it not work with the events bridge?
no, that is yeah, that's uh you know I don't know how it will work, but remember how did we discuss Amazon Event Bridge? When an event happens, right? It is
Yes.
passing through the event bus, and then if something reads it, it takes it and put to a target. That is something else. You can't do it because what would be the event? If you have an EC2 instance, you mean that in an EC2 instance, an event that the dictation is different.
Ah, okay.
That's that's much more different, yeah.
Yeah.
So AWS has created this especially for because you also realize that maybe to patch your systems, you may want to combine different in a different way. And that's where you see in AWS, they'll ask questions at times, which one is the most cost effective, which one is the most highly available, and things like that. There are some ways you can decide and say, okay, you may want to do something some differently. But AWS has created this service mainly for to do patch, to manage patches in systems. And if you see a question where system manager is mentioned as one of the options and it has to do with patch manager, except something else is stated that really takes it away, you should think of picking the AWS, the systems manager. Because AWS always encourages also that for the services that they have created and specify that this is what is used for. So if you come to a question and you see it, use but it, right? Like you see, system manager also have what is called session manager. This session manager makes it possible for you to connect to an EC2 instance. We have connected to an EC2 instance using PuTTY, but session manager is one of the most secure way to do that without the need to open ports, maintain bastion hosts, or manage SSH keys. Because each time you download the SSH key and store on your computer to use, there's a risk that someone can get it and connect to your computer. The session manager With Session Manager, you don't even need keys. So it's a much more secure way to connect to your instance. We'll see that again later. Right? You can use Session Manager to connect to your instance without using keys. So take note of this. There are three key things here. These 3 points here are just, if you are looking at a question, you see Session Manager, which falls under AWS System Manager, SSM. You also have what is called a run command. With the run command, you can remotely and securely manage the configuration of your managed nodes. Take note, securely manage the configuration. How is your instance configured? So if you want, so these are all things that System Manager is capable of doing. Apart from doing patch management, apart from being able to connect to instances without SSH keys, you can also use what is called a run command to remotely manage the configuration of your managed nodes. So maybe you will want to get to your instance and somehow, we're talking about the configuration. Maybe do some changes, configure it. You can just send a command that can go do that. A managed node in an Amazon Elastic. A managed node is any Amazon Elastic Compute Cloud instance or non-EC2 machine in your hybrid and multi-cloud environment that has been configured for System Manager. So the first thing is, when you have an EC2 instance, you have to ensure that it's configured to use System Manager. And it's not something complex to do. If you notice, I was showing here and I showed an instance I have that is configured to use System Manager. So once you have an instance configured to use System Manager, it is referred to as a managed node, right? So Fleet Manager, managed nodes, I have an instance here running, is configured to use System Manager. And as long as it's here, I can connect to it. I can start a terminal session. I can patch the node. I can execute the run command. You see, execute the run command. So maybe there's a particular command I want to use on this instance. I can just click here. It will take me to execute it. Right, so start a terminal session, execute the run command, view performance counter, view file systems. So those are the kind of tools, reset node user and password and things like that. Those are some of the actions you can take on a managed node. A managed node, again, is an instance that have been configured for systems manager. Let me see if I have an example of a run command here. A run command could be, no, this also manage your instance with a run command. Okay. Let me see. What can I look here? Do I have that? These are examples of run commands. Find Windows updates. Okay, so maybe for a particular, I'm not using, my system is not a Windows machine. Maybe I want to send the command to a Windows instance to look for the latest Windows updates, right? Then I'll then go ahead and click that command and then push it to a particular node, specify the instance where that can be executed. Okay, but what's key again, so that I don't touch to go too far, these are the things you should remember. And then these three different things. In questions, you see this run command. You always come. I think I've seen them again as well. But then if you want to apply patches to nodes, apply patches to nodes, patch manager will help you, system manager. Okay, any other question or thoughts on this? Okay. Now, so I think it's already, I don't want to start another and track it. It's already 9:33. Let's stop here for today and then come back tomorrow and continue and see. We'll slowly wrap up. Yeah. Except any question before we go? Or we are all good. There's a lot of silence.
Please, the elastic beanstalk and the light sail, is it in our slides? Because on these slides for infrastructure as a
You
as
don't
code,
see it?
it's not
Okay.
there.
All right. Let me just check now before we go. If I'm having it on a different slide, I mean on the Google Drive itself. Let me just check now. Okay. Um, and while I'm checking if there's anything, feel free to bring. But apart from that, let me see. Cloud. Where is my... Okay. PDF sites. Okay, I've seen that. Okay, I have this here.
Also, were you able to update the cloud?
This is system manager. Just let's create this. There's a system manager on the, it's here, Hilda. If you look at 020 IaC Cloud Development Kit AWS Works is here. All right, look at this one, 0020 IaC Cloud. It's inside this PDF. Okay.
0020. The last slide.
This is it. Yes. What is
No,
among the last thing we are doing?
yes.
This is it. Yeah. The last slide, 0020.
We're
It's
talking about
on
the
the
elastic
PDF side.
beanstalk and the elastic beanstalk and light sails. It's not on the slides. I'm not
Okay, I
talking
think I
about
have it. I
AWS
said,
System
okay.
Manager.
Okay, I think it's somewhere else. Okay, I have to check where it is. It should be somewhere. Okay, I'll check. I'll check. I'll check that then. Yeah. Right. What
Yes.
else were you mentioning, Hilda?
The cloud adoption framework, I think you have not updated it, right?
The cloud adoption framework.
Yes, we
Well,
still
do
have
you mean the
developer
support
business.
plans?
Yes.
No, that's not under adoption framework. That is the support plans, right? We'll come back to it. The cloud developer framework, you are mentioning on this under support plans, right? There's the
Yes, because they
developer
are,
and the data. Yeah.
yes.
We'll come back to that. We'll come back to that. Yeah. I
Okay.
was saying that we'll come back to that. These ones, some of them are being retired. We have the unified operations coming in. This is
Mhm.
gone. Yeah. So we'll come back to that. Right.
Yeah.
Okay. All right. Sonia, are you there? You and baby. I hope. Okay, then let's leave it here for today. We'll come back tomorrow. Let me stop the recording. Yeah. Thank you all. Have a good night.
Thank you.